Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over graphing rational functions. A rational function is just a function that's a ratio of two polynomials. For example, x squared minus 4 over x plus 3 is a rational function. What does the graph of a rational function look like? Well, let's start with our parent function. Our parent function is f of x equals 1 over x. Let's look at our table of values for this parent function. So we'll go from -2 to +2. When we plug in -2 to 1 over x, we get -1/2. When we plug in -1, we'll get -1. When we plug in 0, we get 1 over 0, which is undefined. When we plug in 1, we get +1. And when we plug in 2, we get +1/2. So what does that graph look like? If we were to continue plugging in points on our table of values, we would find that our graph looks something like this, and that we have asymptotes at the line y equals 0 and at the line x equals 0. An asymptote is just a place where the value of the graph is undefined. We see when we plug in 0 for our x, we get undefined, and that's why we have a place where our function does not exist. This is what the graph of our parent function of rational functions looks like. You can use more values in your table of values to define exactly how this curve works, but this is the general shape of the graph. In general, we write our rational functions as f of x equals a polynomial in our numerator and a polynomial in our denominator. In general, there are some steps we can follow to graph our rational functions. First, we'll find our x and y intercepts. Next, we'll find any holes that we have in our graph. Those are going to be points that we can cancel out in our numerator and denominator, and I'll show you some examples of these. Third, we're going to find our vertical asymptotes. And fourth, we'll find our horizontal asymptotes. Lastly, we'll sketch the graph. Now, when we talk about finding asymptotes, here are some asymptote rules. For any value of x where the denominator equals 0, there's a vertical asymptote. Keeping in mind our rational functions have the form f of x equals ax to the n, some polynomial, over bx to the m, some polynomial. If the degree of the numerator is less than the degree of our denominator, then our asymptote is at y equals 0. If the degree of our numerator is equal to the degree of our denominator, then our asymptote is at y equals a over b. And if our degree of our numerator is greater than the degree of our denominator, there are no horizontal asymptotes, and instead we have a slant asymptote, which we find the equation for that line by dividing our numerator and our denominator. And I'll show you an example of this. Now that we know the steps to graphing our rational functions, let's take an example of graphing a rational function. Let's take the example f of x equals 3x plus 6 over x minus 1. First, we want to find our x and y intercepts. So to find our y-intercept, we'll set x equal to 0, and to find our x-intercept, we'll set y equal to 0. To find our x-intercept, we'll set our numerator equal to 0. Next, we want to find any holes. To find holes, we want to factor our numerator and denominator and identify any common factors that we can potentially cancel. So in this case, our function 3x plus 6 over x minus 1 becomes, in our numerator we can factor out a 3, which means this is 3 times x plus 2 over x minus 1. There are no common factors, which means there are no holes. Next, we'll find our vertical asymptote. To find our vertical asymptote, we set our denominator equal to 0, and then we solve for x. So in this case, we'll set x minus 1 equal to 0. Solving for x gives us x equals 1, meaning there's a vertical asymptote at x equals 1. Next, we'll find our horizontal asymptote. To find the horizontal asymptote, we want to compare the degree of our numerator and our denominator. If the degree of our numerator is less than the degree of our denominator, our asymptote is at y equals 0. If the degree of our numerator is equal to the degree of our denominator, then our asymptote is at the ratio of their leading coefficients, or at a over b. And if our degree of our numerator is greater than the degree of our denominator, there's no horizontal asymptote. Instead, there's a slant asymptote. So in this case, the degree of our numerator is 1 and the degree of our denominator is also 1, which means we're going to use b to find our asymptote. We're going to compare our leading coefficients, which are 3 and 1, which means our asymptote is at y equals 3. And the final step is to sketch the graph. To sketch this graph, let's start with our asymptotes. We have a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 3. We know that there aren't any holes, so we don't have to identify any of those holes. Let's plot our x and y intercepts. So we have a y-intercept at -6 and an x-intercept at -2. So this means we will have a portion of our graph in this bottom left quadrant, kind of like in the area where our third quadrant is, will be a portion of our graph, and the other portion of our graph will be in our first quadrant at the top right of this graph. So now we can just draw a rough sketch. This graph will look something like this. Now let's look at some more examples of following these steps to graph our rational functions. First, we have f of x equals x minus 2 over x minus 4. So first we want to find our x and y intercepts. For our y-intercept, we'll set x equal to 0. So f of 0 equals 0 minus 2 over 0 minus 4, which is equal to -2 over -4, or positive 1/2. So our y-intercept is at 0, 1/2. For our x-intercept, we'll set our numerator equal to 0. So x minus 2 equals 0. Solving for x gives us x equals 2. So our x-intercept is at 2, 0. Next, we want to identify any holes. In this function, we cannot simplify our numerator and our denominator. Therefore, there are no holes. Next, we want to identify our asymptotes. So let's start with our vertical asymptote. So our vertical asymptote can be found by setting our denominator equal to 0 and solving for x. So x minus 4 equals 0, add 4 to both sides, and we get x equals 4, and that's our vertical asymptote. Next, let's find our horizontal asymptote. Here, our degree of our numerator is 1, and our degree of our denominator is also 1, which means we are going to use the ratio of our leading coefficients. So we're going to take that numerator and denominator. We have y equals 1 over 1, which equals 1, and we have a horizontal asymptote at y equals 1. So our last step is to graph. So let's start with our asymptotes. We have an asymptote at x equals 4, that's our vertical asymptote, and a horizontal asymptote at y equals 1. Next, let's plot those intercepts. So we have an intercept at 0, 1/2, and at 2, 0. So we can see just based off our intercepts that we're going to have a portion of our graph in the bottom left-hand quadrant of our asymptotes, and then the other portion will be in the top right. So we can graph that, sketch that shape. And this is the sketch of our graph. For our next example, we have f of x equals 1 over 3x squared plus 3x minus 18. So first, let's find our intercepts. For our y-intercept, we'll set x equal to 0 and solve for y. So when we plug in 0 for x, we get 1 over 3 times 0 squared plus 3 times 0 minus 18, which is equal to 1 over 0 plus 0 minus 18, or just negative 1 over 18. So our y-intercept is at 0, negative 1/18. For our x-intercept, we'll set our numerator equal to 0, 1 equals 0, and this is not true, so this means we have no x-intercept. Next, we'll identify any holes. Our holes exist where we can simplify our numerator and our denominator. In this case, our numerator is just 1 and our denominator is that polynomial. There's nothing we're going to be able to simplify, which means there are no holes. Next, we have our vertical asymptote. So our vertical asymptote is going to be where we set our denominator equal to 0. So we want to solve for x. We can factor out a 3 and get x squared plus x minus 6 equals 0. Then we want to factor this further. This becomes 3 times x plus 3 times x minus 2. And then we're going to set each of these binomials equal to 0. We want to find all the places that make x equal to 0, which means x plus 3 equals 0 and x minus 2 equals 0, or our vertical asymptotes are at x equals negative 3 and x equals 2. So this graph has two vertical asymptotes. For our horizontal asymptote, the degree of our numerator is 0 and the degree of our denominator is 2. So since the degree of our numerator is less than the degree of our denominator, our horizontal asymptote is at y equals 0. And the last step is to graph. Let's start by plotting our asymptotes. So we have a horizontal asymptote at y equals 0, which is right across our origin. And then two vertical asymptotes at x equals negative 3 and at x equals positive 2. Next, we don't have any holes that we need to identify, so let's plot our x and y intercepts. We don't have an x-intercept, just a y-intercept, and that y-intercept is at 0, negative 1/18, so almost at our origin. And now we can sketch the graph. Whenever our rational functions are broken up into 3 sections like this, you're always going to see 2 sections like we saw before with kind of that L shape for our graph, but then we're also going to have a parabola. So in the top right, we're going to have our L shape, just like normal. Then in the middle here, we're going to have a parabola. As we go across our asymptotes, we're never going to see our graphs directly next to each other. We're always going to be alternating. So since we started in the top right, and we have this point down here at 0, negative 1/18, we know we're going to have our parabola shape down at the bottom, and then we'll come back up to the top with another L shape. And that's the rough sketch of our graph. Next we have f of x equals x to the third minus 9x over 3x squared minus 6x minus 9. So first we want to identify our intercepts. For our y-intercept, we'll plug in 0. So f of 0 is equal to 0 to the third minus 9 times 0, all over 3 times 0 squared minus 6 times 0 minus 9, which is going to be 0 over negative 9, or just 0, meaning we have an y-intercept at the origin, or 0 over 0. For our x-intercept, we'll set our numerator equal to 0. We can factor this. We can factor out an x, so we want to do that. We have x times x squared minus 9 equals 0. So x equals 0 and x squared minus 9 equals 0. Solving for 0 here gives us x equals positive 3 and x equals negative 3. And those are our intercepts. Next we have our holes. So we find our holes wherever we can simplify our numerator and our denominator. We just saw when finding our intercepts that we can factor our numerator. So let's rewrite both our numerator and our denominator by factoring. F of x then becomes x times x plus 3 times x minus 3 all over 3 times x minus 3 times x plus 1. Notice that we have x minus 3 in our numerator and our denominator. That means these can be canceled and we have a hole in our graph at x minus 3 equals 0 or x equals 3. And this also means that we cannot have a 0 at x equals 3 because there is a hole there. Next, let's find our vertical asymptote. So for our vertical asymptote, we want to set our denominator equal to 0. We just factored that, so let's use the factored version, which is 3 times x plus 1 times x minus 3 equals 0. We already know x minus 3 is a whole, which means we're just going to use x plus 1, meaning we have a vertical asymptote at x equals negative 1. Next, we have our horizontal asymptote. For our horizontal asymptote, we want to compare the degree of our numerator and the degree of our denominator. Our numerator is 3, our denominator is 2. So that means that the degree of our numerator is greater than the degree of our denominator, and we do not have a horizontal asymptote. Instead, we have a slant asymptote. So this means we want to divide our numerator and our denominator in order to find our slant asymptote. So I'm just going to work this out quickly. If you don't know how to divide polynomials, you can check out the video that I have on dividing polynomials linked here and also in the description below. When we are finding our slant asymptote, we don't care about the remainder. We just want to know what our function is. So our asymptote is going to be at the line 1/3 x plus 2/3. Now let's graph. So we have our vertical asymptote at x equals negative 1 and our slant asymptote at the line 1/3 x plus 2/3. So we call it a slant asymptote because it moves on a slant. So that looks like this. Next, let's plot our intercepts, which are at 0, 0 and x equals negative 3. And then we'll sketch this graph, keeping in mind where our hole is. So if I sketch the left side of the graph, we have something like this. And our asymptotes help us to shape this graph. And then for our right side, and then there's a hole here at negative 3. And then we keep going this way. And that's the graph of this function. For our next example, we have f of x equals negative 4 over x squared minus 3x. Let's start with our intercepts. So for our y-intercept, we'll set x equal to 0, and we get negative 4 over 0 squared minus 3 times 0, which is undefined, which means we do not have any y-intercepts. For our x-intercept, we will set our numerator equal to 0, and this is not equal to 0. Negative 4 does not equal to 0. We can't solve for x, which means there's no x or y-intercept. Next, let's identify any holes. When we expand our denominator, we're not going to be able to simplify anything. Therefore, there are no holes in this function. Next, we have our asymptotes. So let's start with our vertical asymptote. For our vertical asymptote, we're going to set our denominator equal to 0. So we have x squared minus 3x equals 0. We can factor out an x. X times x minus 3 equals 0. So we have x equals 0 and x equals 3 as our vertical asymptotes. For our horizontal asymptote, the degree of our numerator is 0 and the degree of our denominator is 2. Since the degree of our numerator is less than the degree of the denominator, our y asymptote is at y equals 0. Now let's graph. Let's start with those asymptotes. So we have one at y equals 0, one at x equals 0, and one at x equals 3. Next, we don't have any intercepts. The last part is to actually sketch this graph. We do have a negative 4 in our function. Notice that this function is negative, which means we're not going to be positive on the right and left side in this case. We're actually going to be negative on the outsides of our function, meaning we're going to be in the lower half of the graph. So going from left to right, our L shape in quadrant 3 will look like this. Then we'll have our parabola up here at the top. And then we'll have our another L over here on the right side. So because we have that negative in front, this is what the sketch of our graph looks like. Next, we have f of x equals x squared plus 2x over negative 4x plus 8. Let's start with our intercepts. For our y-intercept, we will set x equal to 0 and solve for y. This is equal to 0, which means we have our y-intercept at the origin. For our x-intercept, we'll set our numerator equal to 0 and solve for x. Here we can factor out an x, so we'll get x times x plus 2 equals 0, and get two x-intercepts at x equals 0 and x equals negative 2. Next, let's find any holes. When we expand our numerator and our denominator, we get x times x plus 2 over negative 4 times x minus 2, which means we have nothing can be simplified, so we have no holes. Now let's find our vertical asymptote. For our vertical asymptote, we want to set our denominator equal to 0 and solve for x. So we have an asymptote at x equals positive 2. For our horizontal asymptote, let's compare the degree of our numerator and our denominator, and our numerator is greater than our denominator, which means we do not have a horizontal asymptote, we have a slant asymptote. So we want to divide our numerator and our denominator. So our slant asymptote, again, we don't care about a remainder, so our slant asymptote is at the line y equals negative 1/4 x minus 1. Our last step is to graph. We have our vertical asymptote at x equals 2 and our slant asymptote at y equals negative 1/4 x minus 1. So let's plot those. We don't have any holes and we have a few intercepts. So we have an intercept at 0, 0 and an x-intercept at negative 2. So our graph looks something like this. Thank you so much for watching. I hope you enjoyed and I hope you learned something. If you have any questions or if there are any topics you'd like for me to go over, leave them in the comments below. Also, make sure you're subscribed so you never miss another video. See you next time.